Okay, I think we are back to live. Let's start live in Twitch as well. Sorry. I think everything seems fine. Do you hear me? Let's check in a minute. Okay, we have this. Yeah. I hope you don't hear that hear my dog barking outside. So just wait a minute. I think now you can hear me clearly. Okay. It seems everything is fine. So let's just start. So, sorry for that. Are we live on Twitch as well? Am I live on Twitch? Where's the Twitch? Twitch. Come on. Yeah, we are live on Twitch as well. Okay. I just shared this to the send it, send it, send it. That's it. So where we are now. Okay, so where we are now, I think we are in this part. Fourth chapter, we covered this stack and heap thing, heap memory. and we covered about functions, memory allocations, and we covered about this thing called ownership. And next thing we just covered about borrowing and this slice thing. So okay, that's it. So now we are just going to next chapter, which is reference and borrowing. So this is, I think we already talked about reference and borrowing a lot, but still but I'm sure we didn't cover this chapter yet. But okay, let's go through. But go through fast. So okay, so the reference and borrowing thing is nothing but you can simply think of it as a reference means basically you have something in your memory, some data, and you have address for it, and you have, in order to access this address, you need to you need some variable, right? You need some variable to access that, whether it's a variable or a pointer or but something you need to access that. You cannot um so I think you understand what I'm getting at, right? So you need to have something in order to access the address. You need to something like a pointer or a variable or something like that. So that is what it is. It just simply referencing means you just reference some address in the memory, and you can access the value of it. So that's it. So this reference, there is two kind of reference in Rust. So normally in Rust, you know, in other language you can do a lot of things like you just need to need a reference, and you can do both, change the data and inspect the data. You can do the both things. But in Rust it's not like that. It's a different thing in Rust, which is basically you need to specify that if you are going to modify the data or you are going to just inspect the data. If you want to inspect it, okay, no problem. There is no problem in it. You can do very easily, and lot of you can create many variables as much you want to reference something. I think that is the case, but I'm not sure. But you can create more. But but remember here, you need to careful about this detail called borrowing, which is basically you can inspect what is in the address, but you cannot write them. So that thing is very easy thing. You can do that. You can create a data and store it in some variable in some address, and you have a multiple variable, you create multiple variable, and then pointing to the same address. You can do that, but as long as it's only reach the memory. When it's come to writes the memory, it's a total it's a different story, which is that's why this thing called ownership exists. Because if you want to write the memory, you need to be a owner of that memory. Otherwise you cannot do that. So here you can see that how Rust manages to this how Rust handle this memory thing is because the safety. Okay, this features give you a lot of security to your memory, because now it's not giving us a secure way to access memory, but it's giving a secure way to avoid bugs in your code. Because if you follow these methods, you cannot do that. That's there is no reason to, there you cannot simply do that. Rust won't allow that. So that is why it's safe. That is why it's this language is kind of a safety, right? So that is pretty much it. Reference and borrowing something like something simpler. You borrow some reference. So here you can see the another thing I want to tell you is that I'm going pretty fast. I'm not reading this paragraph. Is because if I'm reading this and go through one by one, it's going to take a very long time. So there is a lot of very beginner stuffs in this as well. So that I can tell you, I can tell you in a short way what is the core meaning of this, so you can understand easily. Then we can move on next. So it's I think we have still have a lot of chapters. It's up to 21 chapters, so we need to cover a lot of advanced stuffs. So still it's not a complete book. I think it cover a lot of the details, but in I don't know, it's cover entire Rust feature. You know, I'm not sure about that, but it is what it is. So now let's just go through pretty fast. So acha. So we are creating some, here we are creating string data type, and we are calling a function, and we are sending address to it. So this address, yes, we are sending the s1 address to it. Basically this thing can take address, but this address is basically inspect only, not you cannot change any kind, change anything within this address. Okay, so it's going to be take address, which is a string address, string type address, and it's going to be return a usize bit. So usize means basically nothing more than that. It's base it's it's kind of a it's kind of a dynamic allocation, where you can, if you are on a 64-bit system, it's going to be a 64. If your computer is 64-bit, it's going to be 64. If your computer is 32, it's going to be 32. Okay, nothing more, nothing fancy here. So that's it, and it's going to be return the length of that thing, and that's it. So the thing here is that, so here we have a s1, this is a variable, and this is a s variable, and this is a ptr means simply a pointer. This thing is the s variable is the actual owner of the thing. Okay, so yes, it's s1 is the actual have the actual ownership of this hello value. And now when you are making reference to it, it's actually borrowing. This s thing is borrowing the s1. So which is basically so now this s thing, s variable, is going to point the s1. So what is the value s1 have is the actual value, right? But it seems little bit confusing for me. Till now I just thought that this thing is separately pointing to this address directly, but now it's let's just see how it works. Okay, first notice that all the tuple code is in a variable declaration, and function returns a value is gone. Second, note that we pass s1 into a function. Okay, in this definition we take a string address rather than a string. This ampersands. I don't know what it means. I don't have any idea about that. Okay, ampersands represent reference, and they allow you to refer to some value without asking your ownership of it. They allow you to refer to a value without the ownership of it. So this is how it works. So that's the thing is same as basically same just as just I said before, so nothing changed. The opposite of referencing by using is dereferencing, where composed with no okay dereferencing operator. Stop. Okay, we will see some uses of the dereferencing operator in chapter 8. Okay, so that is pretty much it. So this is in this way you can avoid S2 access, X2 write access, X2 basically avoid the, how can I put this? So this in this way S cannot write anything in this memory. Okay, write or change anything in this memory. Okay, it only can read what S1 have. You can think of it as like this is pointed to this is pointing to this. It's in kind of a C way. You can think of it as a pointer pointing to another pointer, something like that. Like, let's take a closer look. Function calls. So do we need that? No. S is referencing to a string, and here S goes out of the scope, but S does not have a ownership of what it owns. So it refers to the value it's not dropped. Okay. So here this is one of the, this is very important line. You need to pay attention here, is because if it is a mutable reference, which is basically you are actually transferring the ownership of it. So if you're transferring the ownership of it, if you're going to, if you are transferring the ownership of it and this function is taking that, then you should return something here, which is the address. You should return the ownership back. If you don't do that, if you just forgot to do that, the ownership will be deleted in the memory. Basically mean the data and the address going to be out of scope. So Rust will know, okay, no, the computer will know, so we don't have to keep this data anymore, so it's out of scope, so that we can now delete it. So it's automatically deleted. So you need to, if you want to access this data again in your code, you need to return that. Okay, otherwise you cannot. So that is same like this one, and change. So here what you are just doing, push that here. Wait a minute. It's going to be give us a error because could not compile ownership due to one previous error. Okay, so here you can see is a reference. So the data it refers to cannot be consider changing into this the mutable rate. Okay, so this one thing which is I like the most is that the compiler of the Rust is very good, and you can understand them very easily. The Rust community, I think the Rust, the one of the one of the really good thing about Rust, which I like like most, is that the compiler thing is very handy because you know exactly what is the problem most of the time. So this is the mutable reference. Okay, as I said earlier, this is the mutable reference. So if you want to do this here, you need to be careful here, because once you send a mutable reference to this function, this take it and change something. Here you cannot access that again because it will be out of scope, and this thing is completely deleted in the memory. So you need to make sure it's going to be returned back. So basically mean you're going to return this variable again, otherwise you cannot access it. That's it. And another thing is that, so the mutable references, basically I already said that ownership is only for one person. That is only one owner for memory. So here you are creating a variable called x and assigning a string data to it, and it's a mutable variable. That's just fine. But okay, now let you're creating another variable called x and you transfer the ownership to the r1. Then what you are here doing is again you are creating another variable called r2 and then transfer the ownership of s. So this line, so when it comes to this line, the actually the s variable is actually lost his ownership because it's transferred to r1. Then after transfership to r1, x is just a variable. It does not point it to anything at all. So it's just a variable, nothing more than that. You cannot do anything with it. You cannot because it's no longer a owner of that hello. Okay, it's now the real owner is r1. So you cannot do that. So that's why we have an error here. So first mutable borrow could occur, second mutable borrow could occur, first mutable borrow let and you see here. So that just could not compile. Okay, and let mute as okay. This is so r1 goes out of the scope here. So okay, here we are creating as some variable and here creating another block, and this is what I'm saying. So here you are creating another block, then you are then you are transferring the ownership of s to r1. Once this block executed, then r1 is out of scope here, so we can make a new reference without no problem. So once this block is completed, then r1 is no longer alive, which is basically it's no longer in a memory. It's automatically deleted, right? Then the ownership is basically transfer back to s1. Then you can access it here. Okay, makes sense. So this body is basically saying that okay, as long as you are outside of the body, you can again use the mutable reference for r2. So I'll just give you an example. Just wait a minute. And we have, what is it called? Sorry for that. So um so this is and just wait a minute, what is the problem? So this thing is, so here we just need to open this file and let's just paste with this line. Okay, So the thing you cannot do here is that you cannot do something like create another variable called R3, then you cannot basically do something like this. Okay, it's no longer yes is no longer a ownership of hello, so you cannot do that. And so this basically works, but the another thing you need to pay attention here is that so this is a block, right? So what I'm saying is this is a block. So before that, I just told you that you need to return something. I mean, if you're sending your mutable reference to some block, you need to return the. Otherwise, you cannot get that. Otherwise, you cannot get the reference, get the ownership of the data again. So that's I told you before, right? I just said. But the problem is here we are not returning anything, but still we can access how x we just transfer the ownership to r1. Then how r1 when r1 just transfer the ownership to x, how? Because if r1 is destroyed, everything related to r1, everything r1 has will have to be destroyed, right? So here the ownership is give back, okay, given back. How? Is because this is an expression which is basically it basically evaluates to some value, right? So basically an expression always returns some value. So this expression, once it's finished, it's going to be I think it's going to be returned. It will return. Okay, let's just do something like this. Okay, let's just do something like this. And so it's not a main function at all. Okay, let's create a main function. Fn dot main. Okay, this thing is basically and okay, now it's looks more good. So here we are create a function called check. Okay, and it's going to be take a string, it's a s1, and let's just call it a s1, and it's going to be take a mute string. Okay, it's now it's a mute. It's okay, right? So now let's just print that, so we don't need to okay, let's just print and this is s1. Okay, sorry for that, I just pick up the C habit again. So it says s1, right? Then that's it. So here what we are doing is, let's just come here and call this function call this function check. Wait a minute, it's check, and we are going to send mute. Yes, that's it. So let's just see now. If I'm correct, it's going to be it's going to give error. So what error it's giving? So Here we are accessing R1. So if this is an intentional prefix, oh my god. Okay, no problem. Don't kidding. It's worked. How? I don't understand what's going on here. I just thought that if you are sending a mutable reference, it's going to be change the ownership, and you need to change it back. You need to send it back. Otherwise, the ownership will be maybe what destroyed, right? But here it's not the case, because here we are transfer the ownership of S to R1. Then we are transferring the sending the ownership of S to this function, and we are not sending back. Just basically meaning that once S1 is destroyed, the ownership will be destroyed, right? But how can this happen? Doesn't make sense. Let's ask ChatGPT. Then see what's the answer it give for us. Okay. Hey, I have this function for, sorry for that. I have this code, and explain me why the S1, why after the S1 come out of scope out of scope, and the and yes and yes one is destroyed. Sorry for my English if it is looks bad. S variable and variable S, yes, can have the ownership. I'm really unstable with my typing because I'm not type clearly and fastly. So because I haven't touched the keyboard for a while, it's today I haven't touched it. I need to basically practice. So okay, the answer is your question. After S1 becomes also come up and is destroyed, how the variable X still have the ownership of the value? Okay, this is the exact question we want the answer. We want to know the answer. and this is the ownership. Okay, this is owns the data flow. And borrowing to T, so borrowing, Rust lets to borrowing with a reference. Okay, T is borrowed, immutable reference and mutable reference. Okay, you cannot we cannot have more than one mutable reference at a time. You cannot have both mutable and immutable reference active at the same time. So okay, that makes sense, because but here we are not, once this block executed, this is going to be deleted. So here we are basically accessing mutable reference twice. So this is executed, then it's destroyed, then only we can execute this. But the problem is, how can this function even executed, then this thing code works. Okay, so let's just see what GPT says. Okay, and what happens step by step. R1 is immutable variable, exists only the inner block. Once the end of the block R1 was the borrow ends. It's okay, it's a borrowing. Mute. I don't understand what you're saying. This function takes a mutable reference. Okay, you are passing a new mutable borrow to s, borrow of s to the function. Its argument goes out of the scope, borrow ends. So this is now okay, no previous mutable references active. The thing. I'm really sorry about this. Oh my god. How then? How can, wait a minute? Then how can we just move the reference? Ah, I think now I am get it. I'm feeling like a total stupid. I feel like a stupid. Okay, hello bro. Archi creation. Hello bro. Uh, is there anybody in there in Twitch? It's a silly mistake. It's really a silly mistake. It's basically, I just, okay, the mutable reference is not a transferring ownership. So it's a different thing. It's my bad. It's my fault. Sorry. I really apologize for that. Yes, there is a difference between mutable reference and uh, ownership. Okay, here we are moving the ownership. Here we are basically borrowing the thing. I just, sorry for that, really sorry for that. I just messed up. Okay, but now that we understand now what it is, so let's just move next on. But if somebody watching my live and they just believed what I just said, and they just if they just leave the live without knowing that I just which is just which I said was wrong is really really making me sad. No, so but I'm lucky here because is because now one now how many people watching our live? Okay, it's only one person, but he is still watching, so he know what it is and what's the mistake I just made. But okay, luckily I don't. Luckily, many people isn't watching my live. It's embarrassing, right? But mistakes. I'm a human, so it's a nature, right? But really, I should avoid making mistakes again. Okay, so no problem, no problem. So that's why here we are. That's why here we can able to access here again because the ownership is never transferred here. So both of them are borrowing. So if we just do something like this and something like this, and this will really wait a minute. Let's just put something like set relative number or something like that. Yeah, it is relative number. Now I can jump very fast. So now we don't need this. Um, okay. So now it's going to be an error. It's because now we are transferring ownership, not borrowing cargo run. Oh my god. Cargo run. So this is why is because value is moved here. So we no longer are going to be accessed. That's it, right? Okay, let's move to the next part. So here what the borrow big problem is because both here we are actually we are so in the same block we are doing both mutable and immutable reference, so it's a big problem. We cannot do that basically. Immutable mutable borrow occurs, so that cannot be that cannot be basically present at the same time. We need to get rid of one. Kind of interesting case. Variable R1, R2 will not be used after this point. Let's just see whether it's work or not. Okay. Okay. But if we change this line to this, would this work? I don't understand. But I am trying to understand. Let's just delete this line and put it back here. Okay. And let's just pick okay. Just copy this line, bring it back here, and let's just change this to 2. Okay, we here's the problem. Because if this is inside of the block, that makes sense, okay? Because once the block out of scope, it's going to be destroyed. But the thing is, this thing is in the same block, and here we are accessing this. Here we are creating this. Then we are print this. After that, we have after that we can create a mutable variable. Okay, but we cannot access the variable. So what it mean? Why this line giving error when I put here, but when I put here it doesn't give any error? At the same time, I can, when I access this element in here, it gives us a error. So it's kind of like, once you use the variable, that's also doesn't make sense. What's going on here? Let's just come on this line and let's see, can we access this? This is why Rust feel like harder to understand, because you can see here clearly that. So it does work. My question is why? Why? Let's just why when I put this line, when I put this line right, when I put this line here, sorry for that. When I put this line here, it worked. I don't know why. Why it's when I put this line here, it doesn't work. But when I put here, it work. Why? Is it this print thing, print function, print macro do something like that? Is it need to do with print macro? So print macro is basically putting some code in it. So the references go back there and the macro, actually some code is replaced by this macro. So this something to do with print. So not only print, but what is the problem here is that here we are using the variable, both of them. So if we can use them, if once we use that, we we are allowed to assign a mutable variable again, mutable reference again. But if we are not using it, we cannot do that. But another thing is, once you assign the mutable variable, again you cannot actually use the you cannot you cannot actually use the R2 again. But why? Normal reference. So it's kind of confusing. Not kind of, it's confusing. So let's just read it. Okay, users of an immutable reference don't expect the value to be suddenly changed out from the under them. However, multiple immutable reference are allowed because no one who is just reading the data has the ability to affect anyone else. Okay. Reading of the data. Note that. Reference scope start from where it is introduced and continue. Reference scope start from where it is introduced. Is there anybody watching our live? Just okay. It is the problem. We also cannot have a mutable variable while we have a immutable one at the same time. Okay, note that reference allowed because no one. Okay, note that reference scope start from where it is introduced and continue through the last time that the reference is used. For instance, this code will compile because the last usage of this image the print So this reference scope thing is where, so this reference scope thing is a bit weird, but it is what it is. They are saying basically what they are saying is basically what they are saying is the reference scope is started when it is introduced in code, when we are borrowing code. It started, and it end it entered when it entered basically it entered the okay, the scope end when the last usage of it. Okay, uh, you know what I mean. So here we are creating, and this is the last use of that both reference. So then we are creating this, so it's no problem. uh, okay, it is what it is. What am I doing? I fell in a short dream. Do you know that it's the thoughts are really real deal? It's because they are always sticking inside of your mind and disturbs you whenever they have the time. Okay, they are basically saying that. So they are basically saying that we have a mutable reference, okay, R1 and R2, end of the print line where they are last used, which is before the mutable reference 3. So this is immutable reference, this is mutable reference is created. Okay, so the scope don't overlaps, which is basically they are not meeting or overlapping. So this code is allowed. The compiler can tell that the reference is no longer being used at this point before the end of the scope. Okay. So the end of the scope, so you may think like this: if it is a end of scope, the R1 and R2 is going to be destroyed. No, it will not it will not be deleted in a memory, because it's still there. It's still there, but it will, as long as you don't you use uh, after mutable reference, after creating another opposite reference, maybe immutable, if you are using immutable or immutable or immutable or mutable, it's going to be a problem. Just wait a minute. Interesting. This is why Rust sometimes feel like a bit harder to understand, but once you get the grasp of it, you're just making fun. You're just doing fine. It's over. Okay. How do I call this? Dangling reference. What it is? Understand? Dangling reference. It is easy to erroneously. I never heard this word before. Erroneously. We are pronouncing. Maybe my pronouncing is wrong, but I never heard this before. Created dangling point. It's a pretty name. I don't know. It's a dangling. What it mean? Dangling. Yeah, pointer that reference a location in a memory that may. English is a good language, but it have lot of names, lot of words. You cannot understand every meaning of it because there is huge number of words in English. What is mean by dangling? Let's just see what is the meaning of dangling. Let's just ask ChatGPT what is means by dangling. Refers to a situation where actually, so another one of the tip you can follow when you're using chat GPT or any kind of AI is that whenever you're switching a topic, just so if you're a technical people, of course, we are streaming Rust. So basically, if anybody watching this stream, they are going to be technical people. They most likely know this trick tip. But even though I wanna, okay, but still we can tell that. Okay, which is if you ever which is yeah, if you ever change your topic, don't chat with the same history bar, which is like here dangling is a different topic, but before we are talking about Rust, right? So dangling are connected to Rust, which is basically we are reading the dangling pointer here. So this is a concept in Rust, But if you ever switch a topic, it's totally different from what currently you are speaking with ChatGPT or something like that. So you better create a new chart or something like you better create a new chart and talk that. So if you are doing something like if you are talking a different topic in the same how to say same panel, so it's going to be make the chat gpt or gpt, this is the GPT-4 model, so it's going to be make the GPT-4 model harder to give a accurate result. It's really harder for GPT-4 to give you accurate result, because all the data is going to be fed every time you message it. It's just a token prediction, right? So in future we are going to cover about a lot of AI related things. So Python AI, we are going to do that. So for now, it's a Rust. So what does dangling mean? Dangling mean freed or moved out of scope. So dangling refers to a situation where a reference point to a memory that is no longer valid. Typically because the valid point to is freed or out of scope. It's just basically mean that no longer valid. Okay. I just have this uh, habit of silently reading. So it's really interfering me here and there whenever I try to read, because I usually read not loud. I basically read it in my mind. So I think that's how most people will read. Some people will read something like this. Hey, it is easy to anonymously create a dangly pointer or something like that. So somebody will do, but most people like so whenever I try to whenever I try to focus on something and read something, it's I defaultly switch to my silent reading instead of read it loud. So in live stream you have to do that, right? If I'm reading very silently, and it's very boring for you, right? It's really boring for you. I know how it feels. It's just boring, just a silent, and you are staring at my face. What is he doing? He's not talking about anything, and just it's so weird and boring. So that's why reading loud make you feel like okay, it's gives some grip to watch. Otherwise, it's kind of a pain. Okay, the pointer reference to a location in a memory that may have been given to someone else by freeing some memory while preserving a pointer to a memory. In Rust, by contrast, the compiler guarantees that reference will never be tangled reference. If you have a reference to some data, the compiler will ensure that the data will not go out of scope before the reference to the data does. Oh, okay. So here we have a main function, and we are calling this function. It's going to be return this reference. Nothing fancy. But why named lifetime parameter? Expect named lifetime parameter. What it is? Okay, this error message refers to the feature where haven't colored yet called lifetime. Interesting. So we will discuss lifetime in chapter 10. But oh my god, chapter 10. Just explain those concepts here so that I can understand easily. But if you but this book is really beginner friendly. If you are a beginner and want to learn Rust, I highly encourage you to read this book. But if you are disregarded the part about limestone, the message does not contain the key why this is contains no problem with that. This function's returns type contains borrowed value, but there is no value for it to be borrowed from. I don't understand. It's going to be created. What they're saying. This function returns a type contains a borrowed value. Okay. Okay, we returns a reference to the string. We are sending reference after it destroyed. So that's what is the problem they're saying trying to. Am I right? We return a reference to a string. Okay, yes. But okay. Here we don't need all of this. Edit this. So let all this function, all this function triangle. We don't need to do that. We don't need to do anything. I just forgot to change. Yeah. Can I do something with this? Can I do something with this? We have this return. Okay. So it's not going to be work, but just in case, I want to check that. Nothing more than that. So the run is the error is huge. I just same error, huh? Hmm. Why can I return those? So this line is in be written. So that's what they say. This line cannot be returned because once the function is finished, once the function is finished, the s will automatically will be deleted. Okay, now it makes sense. So we cannot do that. Then how can we return a reference? Let's just capital G. Let's just ask the GPT. So hey, in this code, there is a problem of handling pointer, I think. But in case if we we want to return a pointer, return a reference, how can we do that? Now I get it. It's because this is this is once this block executed, this the s is no longer live in memory, so we cannot reference it, which is basically immutable reference or mutable reference, whatever it is. So but we cannot we can transfer ownership. So that but when you create when you get a ownership from when you get a ownership inside of the block, or when you create a variable inside of the block, you cannot return to the reference. You cannot do that. When it's outside of the block, function block, you can return the reference, because even after even after the block executed, block finished, this is going to be run. Same thing for, as long as the variable is in memory, you can use it. If it is not, how could you, right? You cannot do that. Do you ever seen a Primogen live? I think he is in live now. I don't know, but his live is amazing, right? Amazing, and his live is amazing, and he's a, both a really a good programmer, and I don't know, he have decades of decade. I think I don't know exactly, but he, actually his live stream is really good. I don't know other people like that. Whether I know Primogen and his friend called TJ, his live stream. I don't know, yeah, but I will watch his videos, and his videos and live streams are good, very good. There is a lot of coders. So taking reference and returning reference. So returning, we are not returning, we are returning ownership. Still a reference, still a address. Okay, we here we are returning reference, but here we are returning ownership, giving a reference, sending reference, returning ownership, and or have the ownership. R is basically referencing, yes, right? Maybe we can do something. Longer leader. Here, right? So this is okay. Let's just not so R references yes references centered to this function. This yes is compared to here, but now R become the reference of the S directly. So Go in here and return the ownership of that reference. So R becomes the basically reference to S. R is borrowing S. Maybe we can tell that way. Say that way, not everything seems fine. Okay, I understand. Let's just move to this slice type. What is slice type? Slice lets you to reference here contiguous sequence of elements and collection rather than the whole connection. Slice is kind of a reference, so it does not have a ownership. So kind of a reference. It is really understand. It is really easy to. It's really easy to look at the code and understand and how to read the entire line because you need to read this amount of line to what actually happening in this line. But if you're familiar with it, it's really good thing. That is what I will do fast. But yeah, I don't know. It's a good thing to do or not. But it's really very it's a efficient method to know very fast what is going on here. So here we have a function and it's taking a reference. It's going to be written usize and it's you know as a bytes and let's just see it works. Can I run this here? No. For I and in byte. This is byte literals. Let's just see what can do. Just call this function. Just okay, it's taking a parameter. I just forgot to put that. Just okay. Now it's on. So it's returning something. Okay, it's going to be return something. Just something like some number. Well, yeah. Okay, learn print and this is ah, I'm making a lot of mistakes, didn't I? I really need to get good at typing because this keyboard is so this is one of the trade you can implement with anything. Just this item trade. Sorry, iter. It's a trade. No, it's not a trade. It's a this is the one actually creating this iterable thing. How I don't know how can I put this exactly, but as we get more deeper, we will understand what it is. I think. Nobody is there. Nobody. Nope. Hmm. Never ever give up. So we are not going to give up. We will discuss iterators in more detail in chapter 13. For now, note that iterator is a method that returns each element in the collection. The first element of the tuple returned from the enumerate is the index, and the second element is reference to the element. This is a bit more convenient than calculating the index ourselves, because enumerate method returns a tuple, and we can use patterns to destructure the tuple. In the for loop, we specify a pattern that has one for index, another index, the tuple. Okay, method returns a tuple. Okay. We can use patterns to destructure the tuple. We will discuss patterns in more detail. In for loop, we specify a pattern that has I for the index and the tuple, the single point in it. We get a reference to the element. Oh, okay, mute s is a string from. Sorry for that. I'm really not paying attention here. What is going on here? We put a string and we will check whether a value is. We convert our string to an array bytes using a method. Okay, we create an array iterator over array of bytes using an iter method. This is the reference of the item in this, each item in this. So this is a tuple, and it's going to be have a index and that reference of the item, and it's either we will see that and enumerate. So iter is a method returns each element in a collection that enumerates wrap the result of the iter and wraps the result of the iter and returns each element as a part of a tuple instead. So this returns each element in the byte, and this wrap take that element and put it in a tuple with the index. I think so. That is what I'm thinking. And the first element of the tuple returns from the enumerate is the index. Okay, the first element of the tuple is enumerate. First element of the tuple is enumerate from the index, and the second element is reference to the element. For enumerate in the index. Okay, that's the index. First element is the index, and second element is a reference to that element. Okay, this is a bit more convenient than calculating the index ourselves. That's okay, that's more convenient because the enumerate method returns a type. Enumerate method returns a type. What that means? Uh, Shed. What I'm doing even? I don't understand. It's a tuple. Oh my god, I'm really not paying attention here. Why? Okay, let's just pay attention here. What is here? Okay, because the enumerate method returns a tuple. We can use pattern to destructure the tuple. We will be discuss pattern more in will be discussing pattern in patterns discussing patterns in more in chapter 6. In the for loop, we specify a pattern that has I for the index in the tuple. I really need a practice. We can use pattern to destructure the tuple. We will discuss patterns more in chapter 6. In the for loop, we specify a pattern that has I for the index in the tuple, and has I for the index in the tuple, and because we get to reference to the element in the for loop, we will specify a pattern that has a I for the index in the tuple, and this for the single byte in a tuple, because we get a reference to the element from enumerate. We will use we use pattern. Okay. Just wait a minute. Paying attention is a real skill, you know that, right? It's a it's a real skill, which is that focus on paying attention. It's a real skill. Attention and focus are different thing, but they are closely related. So it's really a good. It's a great skill. Learn to pay attention. Learn to focus on something is a real skill. Without driving into the thoughts. That's why is reading us nowadays feels very hard because uh, after 2000s, I mean after 2010, 2K kids can call it that way. After 2K, there is most people are born after something like after 200 uh, 2000s, and those people is really most people will really struggle to read focus. It's because they are the one first see this emerging of internet. So I'm not yeah it's they are the one see this emerging of internet, and they are still young. While the internet is emerging, they are still young, and at the both time, not only internet technology is improving, and they are more and more adaptable to this video moving representations of information. You can think of it that like that way. Reading is different than watching. If you learn something through watching something like in a video, if you learn something by reading, it's a total different thing. It's because watching it's a total different experience, and um, most people after who are born after 2000s will will be adapted to this technology moving I mean video, because they are really access to internet and something like that. But it's really hard for them to sit and read it for a while because they never used to, right? That's not their how the childhood. Yes. Okay. So it's really hard for them to sit and read is because their mind is never wired that way. Instead they can learn a lot of things by watching others or watching videos or something like that. But but the thing about reading is it's feel like a special is because reading, when you learn something by reading, you need to focus on every details of it. Okay, it's maybe I would say it's kind of active learning. So doing something is active learning, reading something is active learning. But while you are watching something, some videos, right? You are watching something and you are just observing the concept. That's not active learning, it's kind of a passive learning, right? you're okay. So you sometimes, yeah, you're pay for, yeah, you're pay attention to it. Sometimes you dragged off. Okay, when you do that, you just you just move on, right? But in reading you cannot do that. Is because if you just misses a single line, you are going to be you will not continue that. You cannot continue the next thing, because you just missed that exact information. You just miss the some information, sorry, yeah, some information which is basically, which is sometimes it's very important. Okay, sometimes it feel so the thing I wanted to say is that reading is harder than learning something through reading is harder than learning something through watching. It's a totally different thing. So reading something requires attention and the chain of thoughts. Basically, okay, I'm reading something here, there is some information here, and that just okay, they mentioned some information at the top of the line, and they use that information somewhere here. So you need to remember that, okay, oh, that is he said that before, or something like that. So it's really hard. Maybe maybe even after you turned 2 or 3 page, they use that information which is in the first page. So you need to remember that, right? The this chain of thought and the think about paying attention is really crucial in reading. So I would say high reading is the best way to learn something. I mean, reading and by doing something, because both of things get you to focus on that thing. It makes you to focus on that thing. If you're watching videos or something like that, maybe you sometimes drag it off into the thoughts, you're thinking somewhere and you're just not focusing, and then you come back and then watch some clip, then okay, oh, this is what it is. So by watching you can get familiar with it. So that's the one of the thing you can do with watching is really what the when you learn something through video, the motions or pictures or something like that, you can easily get a familiar you can easily get familiar with the thing you want to learn, okay, which is you are learning through video. So but in reading it's you will not, you cannot do that, because if you're not paying attention, you don't understand the concept. If I'm not paying attention to this line and this line, and I'm starting from here, it will not make any sense for me, because I'm starting in the middle of the line, right? Doesn't make sense. But after I finish this, it's really hard for me to get familiar with the thing what I just read. It's really hard. But video is not like that. It's when you watch something, even though you are let's say you are watching a video, it start from here and going here, we are going here. When it's come to this point, you are not paying attention, and you are not paying attention for this line, then you are paying attention this, okay, okay, then for this now you are paying attention, then you are not paying attention this, then you are paying attention. And if you do the something like this again and then you think that, oh, I understand this, but you are not understand this, but you are get familiar with this very easily. You just get familiar with this. Okay, this is you know the name, and you know this basic, very basic, something like a metadata. You can call it as a metadata, data about the data, something like that. You know something, that thing, you know something about that thing. but reading is a different thing. When you do something, you are paying attention this, and you are not paying attention this, and you are paying attention this. When you start this, even when you start the line, even in cost two words, you know that it doesn't make sense. Where am I just missed it. I just need to go back here. I just need to start from here again. So you can understand them very quickly. So you are just dragged off and you need to start over again. But in video you cannot do that. You just basically uh, busy with those different channels, so it's really hard for me to get. So I would highly encourage you to learn something through reading and action. So it's really great way to learn rather than watching videos or something like that. Sometimes I do that. I feel like a really I feel like a stupid whenever I do that familiar thing, because that thing is really so. So but on the way you can check is you have a really good attention or not is by reading. Once you read for a page or something like that, you know how focused you are. For knowledgeable people, or who are for that's not the right word. Maybe we can tell this way, who are working in who are working with like coding, these kind of like, which requires you to think about something deeply, understand something. It's an maybe you can call it as a blue collar job or something like that. Something like you don't use your physical strength, but you're using your mental strength. So it's focus is something like a sword. Uh, if somebody is a swordsman or something like that, who is really good at sword. Okay, so that person is sword is really important for him. Without the sword, it's, uh, it's nothing. Okay, so it's the same thing for those people. Without the focus, uh, without the focus, uh, these persons who requires who have to use their knowledge to do their job, uh, without the focus they are nothing, because you cannot learn something without focus and stress. um, it's for it's like for a swordsman, how important the sword is for a mentally working person or something like that, who requires their mental energy to do their job, will be focuses same as to the sword to them. Okay, so that is how it is. Okay, we just crossed the 2 hours, and I know we are not doing today very well. I can see that very well. I can say that at least uh, it is what it is. Okay, and but we just covered two important topics. But slicing, we haven't covered that yet. We, yeah, 2 hour passed, but still we just covered only one topic. Okay, I need to get more practice. That's for sure. I can tell you that 100%. Okay, I need to get stronger. That is what I have to do in order to get my best. There is no easy way. Okay, tomorrow I will come this same time. If you like my video, if you like my stream, uh, hit the button and subscribe to our channel and share with your friends. If you find the stream useful. And okay, 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 but I think you have a good day. Have a good day.